So I'm going to talk a little bit about the Cerbo GX that we've got here. The Cerbo GX is basically a communications hub for the Victron network. The Cerbo GX has outputs for a display screen. It's actually a touch screen. And that I've got mounted inside the rig, and you can actually see the HDMI cable right here coming off of it. This also provides power to it from the USB port that's right next to the HDMI connector. As we look here, I just kind of ran that cable over. It kind of disappears and goes up the wall back in there. So we'll get to the control panel here in a little bit. But the Cerbo GX, I've got, like I said, the USB power for it. I've got a number of other connections going into it. And I use it for essentially keeping communication with the shunt, with the MultiPlus, and various other things on the ve.bus, ve.can, and ve.direct communications. So it's got a lot of things going on. It's a great little box. You can actually control everything on the MultiPlus from it. You can set your current limits coming in. You can set the charging current limits. You can set all kinds of different things with it. On the other side of it, you've actually got some other analog inputs. So there's over here, it's kind of hard to see, but I've got some temperature inputs. So I've actually got a temperature probe that's in my battery bay to keep track of the temperature where my batteries are. It is also a heated compartment because I put it in my pass-through storage on my fifth wheel. So my batteries are at less risk of freezing if we're ever camping in very low temperatures. Lithium has issues once you get below basically 0 degrees Fahrenheit when it comes to discharging from them, and charging below 30 to 32 degrees. So that's one of the reasons why I put my battery bank here inside the pass-through storage rather than out in my front bay. Now, on those temperature probes, I have, like I said, the one here in my battery bank bay. I've got one up in the front bay right above my Victron MultiPlus, so I can monitor the temperature in there. The inverter does put off quite a bit of heat, both when it's inverting and when it's charging batteries. There is an internal fan, but it is a pretty closed compartment, so I want to be able to monitor those temperatures inside that compartment to know if I need to try and ventilate it or anything like that while I'm using the inverter heavily. I also ran one more just because there's 4 ports, and I don't need a whole bunch of monitoring of temperatures. I put one on the outside of my rig just to monitor external temperature so that I know how warm or how cold it is outside. I can keep track of that. And of course, the thermostat on the wall for my air conditioning and heat will tell me what the interior temperature of my rig is. So I pretty much have all of my temperature there. There's a number of other inputs that you can do there. I won't really get into those for the purposes of this right now, but there's a lot of different things that you can use with the Victron system. So that's the Cerbo GX as a basic communications hub for the Victron network. I chose to go with Battleborn batteries for my implementation because of their reputation. Not only that, but testing has shown that a lot of their batteries are actually a higher capacity than they even rate them at online as far as their amp hour rating. Many of them have been tested to actually put out more power or hold more power than what their face value rating is. That, the 10-year warranty, and a number of other things. The packaging, they are fairly large, but not necessarily so for almost 300 amp hours each on these GC3s that I've got here. The Battleborn batteries just made sense, plus their support. They're a Victron dealer. They were able to be very helpful with some other things as far as configuring the MultiPlus, properly setting up the settings on it, things like that. So there's a lot of support with them. I will admit it has been a little bit more challenging to get someone on the phone at Battleborn if you just make a phone call over there. However, they seem quite responsive to emails, and that's actually my first approach now to getting a hold of someone over there is to go ahead and just send them an email, and they'll typically call me right back. So that's basically what I've ended up doing there. The way that these batteries are mounted to the floor in my implementation actually prevents me from putting the covers on the negative terminals down there. So I'm not really worried about anything arcing. It's the positive terminals that I'm more worried about. But I did have to actually trim out these covers to make them fit right. Even this center one is probably still not quite seated down correctly. I probably need to trim more material off of it at some point, but it does the job for now. It'll prevent things from arcing on those terminals, and I do know that there's a little bit exposed over here, but I'm not planning on having anything metallic being stored right near these batteries, so I'm not too worried about anything arcing or anything like that. From the batteries, of course, these are hooked up in parallel. So we've got all the negatives connected together, we've got all the positives connected together. We have negative coming off of one end of the string, positive coming off of the other end of the strings. We have a 12-volt battery bank here. Coming right off of the batteries, we have the Victron SmartShunt. This is basically what monitors all of the current that goes in and out of the battery bank. The MultiPlus also has its own battery monitoring abilities, but I feel like it only knows how much power it's producing. It doesn't know how much is actually going to the batteries versus what is being used by the rest of your DC system within the RV, such as lights and your water pump, and if you have tank heaters that are 12 volts and things like that, those are going to be DC loads. Some folks have DC refrigerators these days, things like that. So those types of things will have loads, and the shunt will know truly how much wattage is going in and out of the batteries, and you set the storage capacity of your battery bank in the Victron setup for the SmartShunt. And we'll get into that later on in another video on configuration and settings. So that's basically the battery side of things. And the SmartShunt does have its own cable back here. You can see a little red and black, or red wire and a black wire. They're kind of hard to see, but they basically go up here. The red wire does go to my Lynx Distributor that I have up in my front bay where the inverter is. And the black wire is a signal wire that goes back to the Cerbo GX. So once again, we have the Cerbo GX communicating with it. It is a ve.direct cable, and that cable does not come with it. So just a little things you learn as you go along, that basically you need to order a few extra things to make everything work when you order the components. You know, I ordered the shunt thinking that it would just be ready to connect up to my Cerbo GX. That wasn't the case, so it was another day or two of waiting on an Amazon order to get that. So just keep that in mind, that once you get these components, and they all come in you know, little white boxes like this, they're not really, you know, other than labeling what's inside them, there's not a whole lot to tell you what's in that box, and there's not much documentation. So luckily most of it's pretty simple, but that's where a lot of this there was some hunting on the internet for information to know how to set these up. So additionally, coming off, you know, after you come off of the negative terminal and you got the shunt, we have one more wire, this large 4/0 cable, and that's 4 zeros is the size. It's not 4 AWG, which is 4 gauge. This is 4/0 wire. 4/0 is how it's frequently notated online. That cable goes up to my Lynx Distributor up in the front bay, and I'll get to that here in a little bit. On the positive side, as you come off of the final battery, I've got a fuse here. It's a T fuse. It's basically designed to melt if it's over current, and that's a 400 amp fuse. I know that I can actually handle a lot more than 400 amps off of 3 Battleborn GC3s. I think the continuous power rating is somewhere around 500 amps per battery. So even just one battery would handle the load that I'm putting through this system based on my current needs. However, I figured just for safety's sake and the wiring itself, the 4/0 wire is only good for just over 400 amps in optimal conditions. So I think it was something like 435 or something like that on chassis wiring. So keep that in mind, fuse everything on the safe side, and make sure that you're not going to cause any problems there. After the fuse, I do have a master cutoff switch over here. So most folks will say, oh, well, you know, when I cut off my power and I put my RV in storage, you know, my CO detector and my various propane detector and my landing gears and stuff like that all continue to be powered up. Well, with this master switch, I can kill power to everything. So this basically allows me to, if I wanted to put my RV into long-term deep storage, I can turn that off, and there's absolutely no loads or draws on any electrical components from my batteries. So that's essentially what I do. Then off of the master cutoff switch, again, my power cable goes straight into the front bay. It goes to my Lynx Distributor, which is essentially a very fancy bus bar. The Lynx bus bar will be the next thing I'll talk about here in a moment. So coming through the wall into my front bay from the battery compartment, which is my pass-through storage, I have my positive and negative battery cables coming through there. Nothing is actually touching. I know it looks really close here, but they're actually not touching when I routed them. So essentially it comes into this Lynx Distributor. Side of the wall, it goes into this Lynx Distributor. And the Lynx Distributor, as I mentioned before, is really just a fancy bus bar. I can take the cover off of it here. And now we have the cover off so we can take a look at it. So in here we have basically these two large pieces of metal that are your buses. You have a positive and negative bus. These little covers cover up the lower terminals for the negative side of the bus. Once you connect up your negative wire here, you flip this down, and then you can connect up your negative wire, and you put basically a ANL or a mega fuse in between the two. These are all mega fuses that I have here. So realistically, there's just a secondary safety fuse here. It's the same size as the 400 amp T fuse that we just talked about a little bit ago. This one's also 400 amp. It goes down, and this feeds my MultiPlus inverter. So the factory wiring of the RV essentially all ran through another bus bar that's just over here. So we have all the positive wires going into a bus bar that's contained underneath this cover. And so as part of that, that bus bar is of course, probably the lowest bidder, very cheap, very small connectors, things like that. It doesn't look very robust at all. And the factory wiring is 6 gauge, so 6 AWG wiring. And as most folks know, that's only able to handle about 55 amps of power. So that's essentially what is running your entire RV, is the capability of 60 amps. So straight off of my original battery, which sat in this battery tray that's right here, that I'm now using as a little storage for extra oil for the tow vehicle and water filters and funnel and various other things, I've removed the stock battery that simply had 2 short cables that were not fused, went straight to the positive on this upper bus bar, and the negative went to the chassis ground that's right here. So basically all the grounds go right there for your 12-volt system. From there, some of the wiring goes up to like your leveler system, various other circuits. Another wire goes back to your power distribution panel where your circuit breakers are for the 12-volt side, things like that. So then off of the power distribution panel, there was a pair of wires that went to your charge converter that most RVs have. And that basically was what normally would keep your battery charged before, and also power up your 12-volt system when you're connected to shore power. And it just simply plugs in like a regular wall outlet into the back of your converter panel, and has two wires going to the 12-volt system onto another bus that's inside your converter or your breaker panel, your power distribution panel. So now that we've talked about the factory wiring, where the original battery was, where it connects, things like that, essentially what I did is I removed that section of the system and then connected the wiring basically from the same terminal on the original bus bar. Now it goes over here to its own terminal off of the Victron Lynx Distributor. So this is my main power going to the rest of the rig. This is my positive 12 volt. This is my negative that's going down to the chassis ground. And that's my setup for the rest of the RV. And I've got a 60 amp fuse on there, which should be enough if there's an actual short on there. I also ran power for the Cerbo GX and my SmartShunt to here. That way, you know, they're small loads and they are separately fused on their own right here. So I figured just with the little bit of extra load that they have and the load that the system can use, we're probably right about at that 60 amps. I could have put them on their own, but then I would have needed to put another fuse in here, and I just figured that was not necessary. They can piggyback off of these without any trouble at all. And it does work just fine. I've had no issues with anything flickering or fluctuations or anything like that. And when the inverter kicks on, it can pull a lot of power, especially if you do something like you turn on your air conditioning or something like that. And the lights would flicker pretty good when I would do that. But now I have added the micro air easy starts to both of my air conditioners, and I'll get into that a little bit later on in another episode as well. Talking more about the cables coming off the Lynx Distributor, the power cables for the inverter, they're again also 4-aught cables. They go down, and then they basically go into the bottom of the inverter right down here. You'll also notice that there's a couple of other wires that are there. So this one here is actually for the VE CAN connection that runs over to the Cerbo GX. And then I have a little dongle here that's basically the ve.bus to USB that allows me to connect my laptop and do other programming and flashing of the firmware and things like that on the MultiPlus, which I actually ended up having to do. When I first got it, it would make a really loud humming noise that would resonate through the frame of the trailer, and you could hear it even in the living room inside the coach. And this basically, honestly, I had regrets. I was regretting installing the MultiPlus in my rig because I'm a light sleeper and my bed sits right above the MultiPlus in this front bay. Luckily, I did some digging online, and this is where, once again, good information is out there. You just have to really find it. But in one of the Victron communities, there was a forum thread where someone had had a similar issue, and they ended up finding out that one of the Victron folks responded and said that they did find the issue. They corrected it with a new version of firmware and to download and flash with the newest version. And once I did that, it was a completely different unit at that point. There was no more strange buzzing. The hum that it is making right now, which these transformers will always have some sort of a hum, but it is almost imperceptible. There is no weird cycling sounds or anything like that from the Victron now, and I'm extremely happy with it. So very pleased with my purchase. Also, once I installed the micro air easy starts, I actually just yesterday had both of my air conditioning units turned on at the same time, running off a battery. Both were on high, and the Victron was starting to complain. The overload light was blinking, showing that it was at its nominal or max output capacity. However, it was doing it, and it ran for 10 minutes without me doing anything. I finally turned them off myself just to not cause damage to the inverter or cause it to actually go into overload. But running both air conditioners on low would probably be just fine, and I'm sure it would not have tripped into an overload or partial overload state. But again, it ran that load just fine without any trouble at all. So overall, I'm very pleased with the entire Victron setup. Mine is actually a very simple installation. Now, you'll probably notice that back to the Lynx Distributor, I've got a couple of terminals that are still empty. These two connections are still not being used on the Lynx Distributor bus or bus bar. What my plan is, and I actually already have, but I have not yet installed, is I have a Victron DC to DC charger that I will put, basically I'll mount up here on the wall, and I will run another cable from that and then run out to my tow vehicle. I will basically route the cable up to the fifth wheel, come out where the pin box basically is, and have DC to DC charging directly off of my alternator. It'll be 40 amps that'll come in from there. The other connection port that's available is also for future planning. If I do decide to go with a solar setup, I'll get a solar controller that will basically have its power coming in here into my DC system. That'll also charge the batteries, or the inverter can run off of that current coming in, etc. So there are some options for expansion. You know, you can also add multiple Lynx distributors. You can daisy chain them together. You can actually, these terminals here on the end of it, they basically the tabs coming off this end would fit over these, and you can actually chain multiple ones together. You can actually just pull out this little divider right here, and it opens up this port for that to happen. So there is some nice expansion. There is also another Victron shunt that you could put on one end of the Lynx distributors. You can put it on one end or the other, and that's probably the route I would have gone if I had thought about it a little bit more. But I had already purchased the SmartShunt, and so because of that, I don't have the ability to plug into this little RJ11 connector that's here on the end, and that basically would power up this circuitry that would monitor for blown fuses. And so it would basically flash the lights that are on these little holes here if you had a fuse that blew. But since my setup is pretty simple, it's pretty easy for me to find out you know, if a fuse blew or not. You know, a simple check for continuity across these two terminals would tell me if a fuse is blown or not, and it would be real quick to troubleshoot. So it's not too big of a deal. I do lose a little bit of functionality not having that particular shunt here with the Lynx distributor, but it's okay. Earlier I had mentioned that I ran a few different temperature probes into different compartments. And as an example, this one up here that's connected to this bolt is right above my MultiPlus. And so that can basically monitor the temperature of the heat around the MultiPlus. And so that's what that little device is there. I also ran one down under here, kind of runs along my wiring, and out where my hydraulic brake line runs for my hydraulic disc brakes that I have. And it just goes up under the rig. So we'll go here and take a look, and I've attached it basically just to a chassis bolt right there, so I have outside temperature. So that's kind of a convenient little thing to have.